Alright guys, so it's Monday, April 6th. I hope you enjoyed your weekend. I actually went to go visit my mom for the weekend because her birthday was this past Wednesday, April 1st actually. Her birthday, fun fact, is on April Fool's Day. No, I did not play any pranks on her. It's her birthday. That'd just be me. So today's lesson we're going to be solving exponential equations. That's actually what we did the last lesson also. The only difference between the two is last week we did where you only had to change one side. This week we're doing the little bit more difficult ones where you have to change both sides. So let's just jump into the first example here. I have 27 to the x minus 2 equals 9 to the x. So the best case scenario would be if these bases matched up already. So if they were already both 9s or both 27s, that's not the case here. The next best case would be if we could change this 27 to be 9 to the something power. Now that doesn't work in this case because if you did 9 to the first, that's 9, or if you did 9 squared, that's 81. So neither of those cases would work to give you a 27. So that's why this is an example where you have to change both sides. Because what goes into 27 and 9? A 3. So then we're going to change the 27 to be 3 to the third power. And then you have the x minus 2 here. And we're going to change the 9 to be 3 squared. And then I'll put the x here. And then it's important to put the parentheses here because whenever you have a power raised to another power, you need to multiply. And not only do you need to multiply, but you also need to make sure that you use a distributive property. So that 3 needs to multiply the x and the negative 2. And this 2 distributed to multiply that x. So then on the left side, you would get 3 to the 6x minus 6. Not 3x minus 6, sorry. So change this to be a 3. And then on the right side, you would get 3 to the 2x. Then cancel out the 3's now that the bases match. Now it's your usual equation that we've been solving since algebra 1. Couple different ways you could solve that equation, but I think the fastest way would be to minus a 3x on both sides. So you get negative 6 is equal to negative 1x. Then divide both sides by negative 1. That way you get the x by itself. So you get positive 6 when you divide. So x is equal to 6. Alright, so you see how we changed both sides there? Now let's do another example of the same thing basically. So again, ideal situation, these would both be 4s, or you would just change the 32 to match the 4, but that's not the case here. So then we need to change both sides. What goes into both numbers evenly? A 2. So 4 would be the same as 2 squared. Parentheses around that. Bring that 3x minus 2 down. 32, just by guessing and checking on the calculator, would be 2 to the 5th power. And then bring down the 4x plus 6. Then to get rid of the parentheses, make sure you distribute the 2 over here. Make sure you distribute the 5 over here. So then that would be 2 to the 6x minus 4. And on the right side, it'd be 2 to the 20x plus 30. Now we have the ideal situation where they're both a 2, so these cancel out. And then 6x minus 4 equals 20x plus 30. And now it's just easy equation to solve. Get the x's. There's a bunch of different ways to solve this one. I like to have the x's on the left side of an equation. So minus 20x minus 20x. So you get negative 14x minus 4 is equal to 30. Then I'll add 4 to both sides, so negative 14x is equal to 34. Divide both sides by negative 14. So then your answer is going to be, guys, you know I'm lazy, so I just leave that as a fraction. Negative 34 over 14. But I'm not that lazy to leave that answer like that. Remember, fractions, gotta simplify them. So 2 divides both numbers evenly, so divide by 2 on the top and bottom, you get negative 17 over 7. So there's your first one. Not the nicest looking answer, but it's an answer. So last example, this one I just threw in some fractions. Remember, it doesn't change anything. What's the only thing that happens whenever you change a fraction? You make the exponent a negative. So again, ideally we want both of these to match, but we can't change either one. We actually need to change both to be a 5. So 25 would be 5 squared, but since it's a fraction, make it negative. And on the right side, 125 would be 5 to the third power, make it negative since it's a fraction. Now, I know these exponents because I've done them so often. You might have to use a calculator to figure it out, or honestly, chances are you've seen these numbers so often by now that you've already caught on. So make sure you use the distributive property. Then, so on the left side, it's 5 to the negative 2x plus 4, because negative times negative. And then on the right side, distribute the negative 3, so you get negative 6x minus 12. Now we have the ideal situation, bases match, cancel, cancel. Negative 2x plus 4 is equal to negative 6x minus 12. Then solve this like your usual equation. So x is on the left side, so I'll add 6x, add 6x. You get 4x plus 4 is equal to negative 12. Then minus a 4 on both sides. You get 4x is equal to negative 16. And then finally divide both sides by 4. And this one actually comes out to a whole number. So x is equal to negative 4. Some of them are whole numbers, some of them are fractions or decimals. I'll accept either way, even though I much prefer fractions. So those are 3 examples of more or less the same thing. Solving exponential equations, where you have to change both sides. So here's your homework. Again, make sure you're going to be changing both sides for all of these. And then the fractions, make sure that the exponent is negative when you change it. As always, make sure you're checking your homework from the last lesson, and make sure you're submitting the homework for this lesson by 8:30 tomorrow morning.